Okay, so today we'll be looking at permutation and combination. It's a long awaited topic. I know you're excited to have this done. So we're going to be going right into it. Permutation is the arrangement of what? Numbers. Example 1, we'll be looking at in how many ways can 3 boxes be arranged in order if 7 different books are available? In how many ways can 3 boxes be arranged in order if 7 different books are what? Available. So how do we solve that? Solution. This is written as 7, permutation 3. These are the 7 different books, and these are the 3 different ways they can be what? Or the 3 different boxes or the space available to arrange this number of books. So how do we do that? One of the books will be arranged in 7 ways, and then the next one will be left with 6 ways. That's the second box. And then the third one will be left with what? 5 ways, or 5 ways. So these are the 3 different ways that the 7 books can be what? Arranged. So when we multiply this, 7 times 6 will give us 42, and 42 multiplied by 5 will give us this is 10, and this will give us 21. So that's 210. So that's the answer for this one. Then we're going to be looking at another example. The more examples we're able to crush, the more we'll understand them better. So in how many ways can 4 books be arranged? Can 4 books be arranged? Can 4 books be arranged in 4 ways or permutated? In 4 ways. All right, so solution. This one, 4 books arranged in 4 ways. Can you see that? This one now, we'll have it as the first one, the first ways, we take 4 and we are left with 3. The next one, we are left with 2. Next one, we are left with 1. So 4 ways. When we multiply it, we have 24. It's just simple like that. Very simple. If you were asked 4 books arranged in 3 ways, this will be 4 permutation 3. And so you just have it 1, 2, 3. It will stop here. So you multiply this and you put your answer down. So that's about permutation. We're still going to look at other examples right away. So stay tuned. Okay, so the next question, in how many ways can, this is number 3, in how many ways can 3, okay, can the first, second, third prizes be arranged in a race if there are 10 competitors? If there are, please don't mind my writing, this is the way I'm staying. If there are 10 competitors, it's not always convenient this way, but that's the only way you can see it. All right, so we're going to be solving this one right away. And the only way we're going to do this is following the same step again. Now, They said we have 10 competitors. How can we arrange the first, second, third position? Now, the first position will be arranged in 10 ways, the second, 9, and then the third, 8. That's just how you see it. So this is written as 10 permutation 3, and that's 10 times 9 times 8. And when we multiply that, when we punch our calculator, we're going to have 720. Can you see how easy permutation is? Very easy. So the next example, before I give you some things to do, because I said it, you're going to have series of exercises to do in this video. The video is quite a long one, but you promised you're going to do it, so make sure you do it. All right? The more you practice those exercises, the more you understand the topic better. So that's why I included enough exercises for everyone. And that will tell me if you watched the video until the very end. All right, so number four, the fourth example for this permutation, we have, in how many ways can the letters of the word measuring? In how many ways can the letters of the word measuring? Can the letters of the word measuring be arranged or permutated? Can the letters of the word measuring be arranged? Permuted. Arranged. Okay, so now, solution. Let's check the word. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9 different letters. These are 9 different letters to be arranged in 9 different ways because they are different letters. Do you understand? So definitely we're going to get 9 different ways to arrange these letters. So it will be written as 9 permutation 9. Do you see that? So what does this one mean? The first one takes 9, the first one remaining 8, the next one remaining 7, next one remaining 6, next one remaining 5, next 4, next 3, remaining 2, and the next 1. So when you multiply all of this family together, you're going to have a very huge number, 362,880. So this is it. 9 permutation 9 will give you this answer, permuted. So right about now, we're going to look at what we call factorials. Very easy. I love this one very well. This is what we call factorials. So let's quickly look at it. Let's quickly look at it. Factorials under permutation and combination. Before I give you the exercise for this one. So, factorials. Now, a product such as 1 times 2 times 3 times 4 times 5 is called factorial 5, and it's written as 5 factorial. So this is how we represent factorial. 5 what? Factorial. So that's all you have to know about factorials. When you have 3 factorial, it means 3 times 2 times 1. Either you write it from 1 to 3 or 3 to 1, still okay. So when you have 20 factorial, you know what that would be. 1 till 20. So that's all about factorial. So let's dive into few examples and let's get used to it. Let's understand it better. So moving straight into it. So looking at the first example, we're asked to prove that. We're asked to prove that 10 factorial over 8 factorial is 90. That's the first question we are given to do. We're asked to prove that 10 factorial over 8 factorial will result to 90. So let's try it and see. Solution. Like I said, this 10 factorial means what? 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Sorry. Do you understand? All over. And this 8 factorial means what? 8 times 7, 6, 5, 4, 3, 2, and 1. Do you get that? So from here, we're going to be striking out what we can find in the numerator and the denominator. Is that okay? So I'll strike 8, strike 7, strike 6, strike 5, 4, 3, 2, and 1. So what am I left with? 10 times 9, and that will give me 90. Can you see we have proved that? Another short way of doing it, instead of doing all this long stuff, you can just say 10 times 9 times the factorial in the denominator, which is 8 factorial. Just stop there. This 8 already means 8, 7, 6, 5, 4, 3, 2, 1. We don't need to start expanding those ones. All over the 8 factorial. No need to expand this one too. So what do? Strike. And then we have 10 times 9, which is 90. So between this method and this one, which do you prefer? Leave it in the comment section for me. Is it method 1 for factorial or method 2 for factorial? Which one do you prefer? Let me know in the comment section. If you've been watching this video from the very beginning to this point, it means you're enjoying it. It means you're gaining value. Please give this video a thumbs up, a very big thumbs up, so that the algorithm will help push my video to other persons who would also gain value like you. And if you're just joining us in this beautiful community of Maths Made Easy fans, please subscribe to this channel. I love you. Thank you. So let's go back. All right. So this is the first example we'll be looking at on factorial. We're going to be looking at another example here. We're going to be looking at another example here. Okay. All right. So the second example, they said, find the value of 12 factorial over 9 factorial. So find the value of 12 factorial over 9 factorial. Sorry. This one again, either you use the long method or the short one, you're still going to get the same answer. But I'm going to be using the short one because I don't want to waste time here. So 12, 9 factorial. This will be 12 times 11 times 10 times 9 factorial, all over 9 factorial. Now this strikes this. We are left with 12, 11, and 10. And when we multiply that, we're going to have 1,320. Sorry, that's the answer. So 1,320 is the answer to this question. So we're going to be wiping the board now. I'm going to, sorry about this fly keep. All right, so we're going to be looking at some exercises that you do. I have 5 of them, 5 of these exercises that everyone would do. Please, if you're gaining value in this video, please leave it in the comment section. I'm gaining value, like right now. Leave it in the comment section. I am gaining value and I love this channel. I am gaining value and I love this channel. So let's go on. Exercise number 1. Exercise number 1. How many arrangements are there? How many arrangements are there using all the letters of the word letters? Using all the letters of the word letters. Using all the letters of the word what? Letters. Oops, 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 oops. It just dawned on me that, sorry, that's not the exercise. I haven't taught that one yet. Sorry. That's not the one for this. Sorry, that's another exercise. Sorry. In how many ways can 5 different books? In how many ways can 5 different books be arranged in order? Be arranged in order. Number 2, find the total number of different arrangements using any 3 letters. Find the total number of different arrangements. Total number of different arrangements using any 3 letters of the word chemistry. Using any 3 letters of the word chemistry. Number 3, how many numbers greater than 100? How many numbers greater than 100 can be formed using the digits? Can be formed using the digits. Can be formed using the digits 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Take notes from that question. No digits being repeated. No digits being repeated. Then the 4th question is, find the values of A. Please hurry up, take this one down because I'll be wiping this board right now so that I can put the 5th question on the board and we can continue with the topic for today. So please, let's write fast. Let's take notes. Okay, so 8 factorial over 5 factorial times 3 factorial b 15 factorial all over 10 factorial times, is it 10? Okay, 5 factorial. Then C, simplify n factorial all over n minus 2 factorial. So that's for the fourth question. We'll be looking at the fifth one here. I assume and expect that you're done with this one. And you should be done with all of them as well, because we have to continue solving. Okay, so the fifth exercise is, in how many ways can the first, second, third prizes, can the first, second, and third prizes be arranged in a class of 20? Be arranged in a class of 20. So that's all about the exercises. 5 exercises for just this one. Let's go into another one. So I'll be wiping this. So arrangements, gracious God. Arrangement including identical objects. Arrangements including identical objects. The formula for this is, place the total number of items that are given at the numerator, and then the total number of the identical objects as well at the denominator. So that's what we'll be using. So number one question, in how many ways can the letters of the word maximum be arranged in order? Be arranged in order. I want to clean this side of the board. So, in how many ways can the letters of the word maximum be arranged in what? In order. Like I said, first thing you're going to do is to bring out the word maximum. How many letters do we have? 1, 2, 3, 4, 5, 6, 7. 7. Are you getting it? So 7 factorial. How many identical letters do we have? Just one, which is M. And how many times does it appear? 3. So we have it over 3 factorial. So this will be 7 times 6 times 5 times 4 times 3 factorial, all over 3 factorial. Strike that out. Are you saying that? So we have 7 times 6 times 5 times 4 to give us, when we punch our calculator, we should have it as 840. So you see how simple this one is. Very, very simple. We're going to look at one more example on this so that you can have some exercises on this one. I told you we're going to be doing lots of exercises, so you just have to, for you to understand this better, you just have to do them. You just have to do them. I'm begging and seriously begging that you don't just watch this video, but you try it out. Just try it out, okay? All right, so example 2, how many different numbers, number 2, how many different numbers, this is quite light because the other marker is saying goodbye, different numbers of 5 objects, of 5, is it digits? Yeah, 5 digits can be made using the digits 22333. Can be made using the digits 22333. So solution. In order for us to solve this, how many different numbers of 5 digits can be made using the digits 22333? Now they said 5 digits. So that's our total. Are you getting it? That's our total. Then we have these numbers, 2 numbers appearing as many times as possible. So 2 appearing twice, so we have 2 factorial. 3 appearing 3 times, we have it as 3 factorial. You get it here. We had m and we represented it by how many times it what appeared. So this is 5 times 4 times 3 factorial all over 2 factorial 3 factorial. Now this 3 will cancel this 3 factorial. So we're left with 5 times 4 all over 2 times 1, because 2 factorial means 2 times 1. So 2 here is 1, 2 here is 2, and we have 10 as the answer. So these are the ways, 10 ways we can what arrange these numbers. Now we're going to look at another one. We're going to look at we're going to look at exercises for this one. Exercise number 1, how many arrangements are there? This is exercises. How many arrangements are there? How many arrangements are there using all the letters of the word? Using all the letters of the word. Letters. Number 2, how many arrangements are there using all the letters of the word? Calculus. Using all the letters of the word calculus. So those are the exercises you do under this arrangement of identical objects. So those these 2 exercises are for you to solve. Please make sure you leave your answer in the comment section. Just try it out. I believe in you. I know you can do it. So all you need to do is just believe in yourself and do it. Thank you. Please, if you have not given this video a big thumbs up and you have been watching up to this moment, what can I do you? please give it a big thumbs up. Thank you so much, and subscribe to this channel. Thank you. So let's dive in. Now, right about now, we'll be going into combination or selection. I'll be cleaning this one. I'll be cleaning this side. Let me see how this marker looks. Okay, it's still good. Let's try this one and see too. So selection, this is fading away. Selection and combination. Selection and combination. In how many ways we'll be starting off? In how many ways can 4 boys be chosen from 6? Can 4 boys be chosen from 6? Solution. Please, this is a question mark. Can 4 boys be chosen from 6? How do we go about this one? This will be written as 6 combination what? 4. And now, this is quite different from permutation. This is how you apply the rule for this one. So the top, the numerator, will use the permutation rule to solve it, and then the denominator will just take this number here in factorial. So in permutation, when we want to solve it, it's 6 permutation 4. Is that not so? All over 4 permutation. So what does this one mean? It means 6 times 5 times 4 times 3. Is that not so? All over what? 4 factorial. Can you see that? So what does it mean to 6 times 5 times 4 times 3 all over 4 times 3 times 2 times 1. So 4 cancels 4, 3 cancels 3, 2 here is 1, and 2 here is 3. Yeah, so 3 times 5, your answer is 15. Can you see that? Super easy. Very, very simple. So we are going to be looking at one more example. One more example before I load you up with some classworks or some exercises. All right, we're about coming to the end of this permutation and combination. Hope you've been enjoying this topic, this super course. If you've been enjoying it, leave your comments in the comment section. Tell me I'm enjoying this course, I'm enjoying this topic, and I've learned a lot. Thank you. Okay, so also you can leave some questions, some topics that you want me to cover. Once you do so, I would definitely make a video on those topics. So please do that for me. Thank you. So the example 2, the second example we're going to be looking at is a committee of 2 men and 3 women. A committee of 2 men and 3 women. Women are always more. Is that true? Are women always more in some organizations? If you think that's true, please tell me yes or no. Women are more, women are not. Let me know in the comment section. A committee of 2 men and 3 women is to be chosen from. Is to be chosen from 5 men and 4 women. From 5 men and 4 women. Full stop. How many different committees can be formed? How many different committee can be formed? Question mark. Solution. So I'll be solving this one here. This is also super simple to crush. We're going to be solving it in two different ways. All right. So we're asked a committee of 2 men and 3 women is to be chosen from 5 men and 4 women. So the first one we are going to consider men, 5 men to be selected, 2 men. Then the other one is 4 women selected, 3 women to form a committee. Okay, so this will be like we did before, 5 permutation 2 all over 2 factorial. Is that not so? So this will give us 5 permutation 2 is 5 times 4. Is that not so? And 2 factorial is 2 times 1. So 2 here is 1, 2 here is 2. And our answer for this one is 10 ways. 10 ways. So let's look at this one. 4 permutation 3 all over 3 factorial. So this will be 4 times 3 times 2 all over 3 factorial. What's 3 factorial? 4 times 3 times 2 all over 3 times 2 times 1. This strikes out, and we have what? Our final answer to be 4 ways. Can you see how easy combination is as well? So now exercises. I have loads of exercises for you. So I'm going to be cleaning this one. I have to be wiping everything. Okay. So exercise 1. In how many ways can 3 equal prizes? Exercises. Number 1. In how many ways can 3 equal prizes? Can 3 equal prizes be given to 5 boys? Be given to 5 boys. Number 2. In how many ways can 4 boys be chosen from 6? In how many ways can 4 boys be chosen from 6? Number 3. In how many ways can 3 men and 2 women? In how many ways can 3 men and 2 women? 3 men and 2 women be chosen from 6 men and 4 women? Be chosen from 6 men and 4 women. Then the last question. Oh, there's something close to the last. Okay, number 4. Prove that A 7 combination 3 is equal to 7 factorial. 7 factorial, 3 factorial times 4 factorial. Then B, prove that 8 combination 5 is 8 factorial all over 5 factorial times 3 factorial. So these are the exercises. You'll be doing them in cross-check. In how many ways can 3 equal prizes be given to 5 boys? 2. In how many ways can 4 boys be chosen from 6? 3. In how many ways can 3 men and 2 women be chosen from 6 men and 4 women? Then prove that this is this, this is this. So this has brought us to the end of permutation and combination. If you've been gaining value from this whole video and you haven't liked this one, please do so. And make sure you subscribe to this channel, hit the notification bell, and I'll see you in the next one. Check up here and watch my next video. Thank you. Bye.